Assalamualaikum students, today we will solve the MCQs of Thermochemistry, chapter 11. First MCQ, the process which once started will continue to happen without the intervention of the outside sources is called spontaneous process. Okay, spontaneous process is the one which occur without applying any external source or without giving any external help to it. Okay, which once started will continue. Okay, so this is the definition of spontaneous process. Second MCQ, melting of ice at room temperature, rusting of iron and combustion of methane are. Now look at here, melting of ice at room temperature is spontaneous process, spontaneous plus it is endothermic. Okay, still it is endothermic. Look at here, rusting of iron, this is spontaneous process but it is exothermic. Okay, exothermic. And combustion of methane, it is also spontaneous process and it is exothermic process. Now look at the option A, spontaneous and exothermic processes. No, because this one is endothermic. Okay, spontaneous and endothermic, this one is incorrect because these two are exothermic. Spontaneous and reversible process, this one is also incorrect because these processes are irreversible process. Okay, now look at the D option, spontaneous process. Okay, so option D here is correct because these all processes are spontaneous in nature. Third, ice can be melted at a temperature below 0 degrees C. Okay, by applying pressure. The process is an example of. So when we apply the pressure, it means that this is a non-spontaneous process because we are using some external sources. Okay, so when the ice melted, it means that it is a physical change. So here option B is correct. Now look at here, how the ice melt by applying a pressure. Here we know that when ice is converted into liquid water. So when we apply the pressure, when we increase the pressure, what happens? We know that when we increase the pressure, then this reaction will move in that direction where the volume is greater, where volume is smaller, Okay, now look at here. We know that volume of ice is greater and the volume of water is smaller. Okay, so when we apply the pressure, when we increase the pressure, this reaction will move in that direction where the volume is smaller. So in that case, the ice is melted at temperature below 0 degrees C by applying pressure. Okay, in this case the ice converted into liquid. So this is the process. When we apply the pressure, then the ice will convert into liquid water because the volume is smaller in case of liquid. So this is the reason that when we apply pressure, then ice can also be converted into liquid below 0 degrees C. Okay, so this is the example of non-spontaneous physical change. 4. If the heat is supplied to a system and work is done on the system. Look, heat is supplied to a system and work is done on the system. Then the first law of thermodynamics will take the form. Now look at here. We know that when we supply heat to a system, then the heat will be positive. Okay, and the work is done. When the work is done on the system, then in this case the work will be positive. Okay, now look at the options. Look, internal energy is equal to Q is positive and work is positive. Here the work is negative, here the heat is negative, both are negative. So here option A is correct. Okay, because heat is supplied to a system, which means it is positive, and work is done on the system, which means that work is also positive. Applying first law of thermodynamics to a gaseous system in which heat is released by the system, which means that Q will be negative. Okay, and work is done on the system, which means that work will be positive. Now look at the options. Internal energy is equal to Q is positive and work is positive. This one is incorrect. Now look at here, option C. Heat is negative and work is positive. So here option C is correct because heat is released by the system, which means that it is negative, and work is done on the system, so it means that work is positive. Heat supplied to a system at constant pressure increases its enthalpy. Okay, this is the definition of enthalpy at constant pressure, which is equal to enthalpy is equal to heat at constant pressure. Okay, so here option C is correct. Applying first law of thermodynamics to a process in which the volume of gaseous system remains constant, we get. Now look at here, we know that Q is equal to change in energy plus P, change in volume, work, okay, or Q is equal to change in energy minus work, okay. Work is positive when work done on a system, okay, and work is negative when work done by the system. So when the volume is constant, it means that the change in volume is constant, is zero, okay. When the volume is constant, it means that the change in volume is zero, so this term will be zero and Q will be equal to internal energy. Now look at here, option B is correct, okay. 8. Conditions under which the standard enthalpy changes are measured at room temperature and 1 atm. This is option D, okay. 25 degrees C and 1 atm. This is 0 degrees C and 1 atm, and this is 0 Kelvin and 1 atm. So here option B is correct, okay. The standard enthalpy are measured on room temperature and 1 atm pressure, or you can write it like 298 Kelvin, okay, 298 Kelvin. The enthalpy change during the formation of 1 mole of a compound from its element in their standard state is called standard heat of formation, okay, during the formation. So it will be standard heat of formation. The formula used for the calculation of the heat of the reaction is, now in order to find the heat of the reaction, here option D is correct, okay. Summation of enthalpy of the formation of product minus enthalpy of the formation of the reactants, okay. This is the formula for calculation of the heat of the reaction. All of the following processes do not represent hydration except. Now we know that in case of hydration, water is involved, okay. Now look at the A option. This is gaseous, and this is solid form. It means that this one is incorrect. Look at the B, gaseous and solid. This one is also incorrect. Look at the C option, gaseous, and this is aqueous form, which means that water is involved here, okay. So option C is correct, okay. And this one is also solid, this one is also incorrect. So hydration means that water must involve in the reaction, so option C is correct. The enthalpy change during the dissolution of 1 mole of gaseous ion in water to produce infinitely dilute solution is known as enthalpy of hydration, okay. This is the definition of enthalpy of hydration, in which water is involved, okay. So option B is correct here. Heat of solution is related to the lattice energy and heat of hydration by the equation, okay. Look here, option B is correct, okay. Heat of hydration is equal to heat of solution plus lattice energy, heat of lattice energy. Here option B is correct. This is the formula for the relation of heat of solution, heat of lattice energy, and heat of hydration, okay. You can also write it like heat of solution is equal to heat of hydration minus heat of lattice energy, okay. Here option B is correct. The amount of heat evolved or absorbed in a chemical reaction is the same no matter the step is. The steps is the statement of, this is the statement of hess'slaw, okay. Hess'slaw says that the amount of heat evolved or absorbed in a chemical reaction is same whether the reaction occur in a single step or it occur in a multiple step. So the amount of heat will be same here, okay. So here it is the statement of hess'slaw. All of the following processes do not represent ionization of sodium except. Now look at here, what is ionization? When we remove an electron from an atom or molecule in a gaseous state, this is called ionization. Now look at the option A. This one is gaseous state, but here it is in aqueous form. So this one is incorrect, okay. Look, this is solid and this is gaseous. This one is also incorrect. This one is liquid and this one is gaseous. This one is also incorrect, okay. Now look at the option D. Sodium is in gaseous form and we have removed an electron from sodium and still it is in gaseous form, okay. So it means that option D is correct here, okay. Option D is correct here. Suppose you have a balloon of given volume V1 containing a gas at temperature T1. When you place the balloon in a colder room at temperature T2, the balloon's temperature starts to drop. What are the signs of the system's Q, work, and internal energy for this process? Now look at here. When the balloon is placed in a colder room at temperature T2, it means that the heat is lost by the balloon. So here when heat is lost, it means that it will be negative, okay. Q will be negative. Now in that case, when the heat is lost by the balloon, it means that the internal energy will be decreases. Okay, the internal energy will be decreases. So it means that this one will be also negative. Okay, internal energy will be negative. Now look at the work. When the internal energy decreases, it means that the work will be done on the system. Okay, work will be done on the system. The size of balloon will be smaller. Okay, in colder room. So when work done on the system, in that case the work is positive. Now look at here, option D. Q is negative, work is positive, and internal energy is also negative. So here option D is correct. 17. Melting of ice at body's temperature is an endothermic process. Okay, like H2O is converted into solid, is converted into liquid, ice is converted into liquid, and it means that it absorbs 6 kilojoule per mole energy. Okay, absorbs. Now thus eating ice contract the exothermic process of metabolizing food. Now look at here again. When we eat ice, it counteracts the exothermic process of metabolizing the food. When we eat food, then what happens? The exothermic process occur, and this food release heat. Okay, and this heat is absorbed by the ice, and the ice is converted into liquid when we eat ice. Okay, now look, how much ice in gram would you have to eat to counteract the energy gained by eating 28.3 gram of peanuts? Considering 1 gram peanuts produce 13 kilojoule of energy upon consumption. Now the required is that when you eat 28.3 gram of peanuts, then what will happen? 1 gram of peanuts produce 13 kilojoule energy. Then how much ice you will eat in order to balance this heat? Okay, now look at here. We know that 1 gram of peanut will produce 13 kilojoule energy. Okay, and also it means that 28.3 gram will produce 13 multiplied 28.3 is equal to 367.9 kilojoule energy. Okay, now 28.3 gram peanuts will produce 367.9 kilojoule energy. Now how much ice will need to absorb this amount of heat energy? Okay, how much ice will need? Now look at here. 18 gram needs 6 kilojoule per mole energy. Now look, 18 gram needs 6 kilojoule energy. Okay, so 367.9 kilojoule will need X. Okay, will need X. Now when you multiply these two and divide it by 6, you will get 1100 gram energy, 1100 gram water. Sorry, not water, ice. Now look at here. In order to balance this heat, in order to counteract this heat, you will need 1100 gram of ice. Okay, you will need 1100 gram of ice in order to absorb this amount of heat. So here option D is correct. 18. In which of the following general chemical systems work done on the surrounding? Work done on the surrounding means that its volume is increases. Okay, volume. When volume increases, it means that the work is done on the surrounding. And the heat transferred from the surrounding to the system, it means that the heat must be positive. Okay, now look at the options. So the first condition was that work done on the surrounding, which means the volume increases. Now look at this option, option A. Here the volume decreases when in the product side the volume is decreased. Now look here, it is 1, it is 2 on the reactant side, and in the product side it is 1. So it means that the volume decreases on the product side. Now look at here, the volume increases on the product side. Okay, the volume increases, so it means that, and look at the heat, it is positive. The heat is transferred to the system, which means that the heat must be positive, Q. So here option B is correct. Okay, look at the C option. Here the volume is same on both sides. Okay, the volume is same because here it is 2 moles and here it is also 2 mole. So it means that C is incorrect. Look at the D option. Here the volume decreases. Here it is 2 mole and it is 1 mole. Okay, the coefficient is 1 here. So it means that this one is also incorrect. Now the work done on the surrounding means the volume increases, and the heat is transferred to the system means that the heat must be positive. So option B is correct. Consider the following figure for SO2. The unknown quantity is, now look at here, we have to find this one, enthalpy. Okay, Look, solid to gaseous, it means that this is sublimation. Okay, liquid to gas, it means that this one is evaporation. And from liquid to solid, it means that this is solidification. Okay, now the formula is like enthalpy of sublimation is equal to enthalpy of vaporization plus enthalpy of what? Fusion. Okay, and sublimation is 32.3 minus vaporization is 24.9 kilojoule. Okay, 0.9 kilojoule. Now this one will give 7.4 kilojoule per mole. Okay, so the heat of fusion is 7.4 kilojoule per mole. But look at here, the required is what? Solidification is required. Okay, solidification is required. We know that from here to here, in this direction it is solidification, and from this direction it is what? It is fusion. Okay, in this direction it is solidification, and in this direction it is fusion. Now we have find the fusion, which is 7.4 kilojoule per mole, but here the required is solidification. Now what you have to do, the formula is heat of solidification is equal to negative of heat of fusion. Okay, negative of heat of fusion. Now here put this 7.4 kilojoule, you will get the heat of solidification is negative 7.4 kilojoule. So here option C is correct. It means that when the liquid is converted into solid, it releases heat. Okay, it releases heat. It is solidification is exothermic process, and the fusion is endothermic because here it is positive. Okay, enthalpy of standard enthalpy of which of the following reaction is equal to the standard enthalpy of formation of NH3. Now what is enthalpy of formation? Enthalpy of formation means that change in enthalpy when 1 mole of the compound is formed, 1 mole. Okay, now look at here, it is 2 mole of NH3, so this one is incorrect. Here the NH3 is not formed, here the H2 and N2 is formed, this one is also incorrect. Okay, look at here, 1 mole of NH3 is formed, it means that option C is correct. This is the reaction equal to the standard enthalpy of formation of NH3. Okay, this one is also incorrect because NH3 is not formed, here the reactants are formed, so option C is correct. Which process is not endothermic? Okay, not endothermic. Now look at here, when we convert ice into liquid, it means that the ice absorbs some amount of heat and then it is converted into liquid water. Okay, so it means that this one is endothermic. This is incorrect. Now look at here, when we convert the vapors, water vapors into the H2 and O2, it also needs energy. Okay, it also needs heat energy, so it means that this one is endothermic and incorrect here. Look, when we convert vapors into liquid, so what will happen? These vapors will release some amount of energy and in turn it will be converted into liquid. So here not endothermic, this one. Okay, this one is exothermic. When we convert water into vapors, we provide heat energy, and when we provide heat energy to a liquid, it is converted into gaseous form. When the gaseous form, when the water vapors releases its energy, then what will happen? It will be converted back into the liquid form. Okay, so here this one is exothermic process. Look at the D option, Al2O3 and 2Fe. Look, these two are in liquid form. Okay, and these are in solid form. Now look at here, when solid is converted into liquid and liquid is converted into vapors, gaseous form. Okay, gaseous. So what will happen? In this direction it will be endothermic. Okay, endothermic, while in backward direction it will be exothermic. Okay, so only this one is exothermic because the gaseous form is converted into liquid form. So option C is correct. Given the following data, here oxygen, it will give boron trioxide. Okay, and ozone is then reacted with boron and it gives boron trioxide. Look, these are exothermic reaction. Okay, these are exothermic reaction. Now calculate the enthalpy change for the reaction converting oxygen into ozone at room temperature and pressure. Now look at here, The reaction is given. Look, 3/2 oxygen in gaseous form is converted into ozone in gaseous form. Now look at here. This 3/2 oxygen, we will get this one from equation 1. Okay, now look, we will get this one from equation 1, and O3 from equation 2. Now the problem is that here the O3 is in the reactant side and here it is on the product side. So when this type of reactions come, what you have to do, you have to just subtract these two. Okay, here it is not necessary for this equation. Okay, so when we subtract these two equations, this will cancel this one and this one will also cancel this boron. Okay, the remaining will be these two. These two will be like 3/2 O2 minus O3. Okay, minus O3. Now if I bring this O3 on the other side of the equation, it will be like 3/2 O2 into O3. Okay, look, the reaction is like this. Now you have to calculate the enthalpy change. Okay, so what you have to do, what you have done with these two equations, you have subtracted these two. Okay, you have subtracted these two. Now take this one and subtract this. Let's suppose I name it like H1 and H2. Okay, now look at here, what you have to do, the enthalpy will be equal to H1 minus H2, because you subtract the equation 2 from equation 1. Okay, you have subtracted the equation 2 from equation 1, that's why here you will put the negative sign. Okay, now look at here, put this one minus 1264 joule minus and minus 1406 kilojoule. Okay, now minus minus will give plus, and when you subtract it will be like minus 1264 plus 1406 kilojoule. Okay, when you subtract these two, you will get plus 42 kilojoule answer. Okay, which of the following sequence of enthalpy associated with the phase change of a particular substance is correct? Now look at the option C. Here it is correct. We know that the enthalpy of sublimation is greater as compared to vaporization, and it is greater as compared to sublimation. Sorry, this one is fusion. Okay, fusion. And enthalpy of fusion is greater as compared to condensation. Now when the solid is directly converted into gas, it required greater amount of energy. When the liquid is converted into gaseous state, it required less amount of energy as compared to sublimation. Look at the fusion. What happened when the solid is converted into liquid, it required less amount of energy as compared to vaporization. Now look at here, condensation. What is condensation? When the gaseous state is converted into liquid, so what happened? It do not require energy at all. Okay, in turn it releases energy. Okay, it releases energy, so it means that here option C is correct. Look, these three are positive, so it means that their enthalpy will be greater, and in this case the enthalpy is negative. It means that it do not require energy, but it releases the energy. Okay, it is negative in this case, so it will be smaller than all the three enthalpies. Which of the following is not a spontaneous process? Okay, not a spontaneous process. Now look at here, reaction of H2 and O2 to form water. This one is spontaneous process. Okay, so it means that this one is incorrect. Combustion of natural gas is also spontaneous. Once it is started, then it will continue. Okay, this one is also incorrect. Neutralization of HCl by NaOH. This one is also a spontaneous process. The required is that which one is non-spontaneous. Now look at here, D is correct. Okay, this is not spontaneous. Synthesis of glucose by plant, because it required the sunlight. Okay, without sunlight the glucose will not be synthesized by the plant, so it means that this is non-spontaneous process. Water can be produced in laboratory by the following reaction. Now look at here, the reaction is given and 2 mole of water is formed. If the HF heat of formation, HF is the heat of formation of water and HR is the heat of this reaction, then now look at here, we have to select the heat of formation. Okay, we know that heat of formation is that heat when 1 mole of substance is formed, 1 mole of water is formed. Now in order to make it 1 mole, we have to divide it by 2. Okay, it will be 1/2 and this one will be divided by 2. Now look at here, option B, heat of formation is equal to heat of reaction divided by 2. So here option B is correct. Okay, because heat of formation is the heat when 1 mole of substance is formed. So you will, and here the heat of reaction is for 2 mole of water. Okay, it is for 2 mole of water. When we divide it by 2, we will get the heat of formation. Sublimation, vaporization, melting and photosynthesis are all the endothermic process. Okay, here option D is correct. Sublimation required energy, vaporization required energy, melting also required energy, and photosynthesis also required the sunlight energy. So these all are endothermic processes. Consider the following figure where X represents an unknown compound. Now look at here. Here X is an unknown compound, and from solid to gaseous sublimation is given, heat of sublimation is given. Okay, look, from solid to liquid, it means that heat of fusion is given. Heat of fusion is given. We have to find the heat of vaporization. Okay, the heat of vaporization. For this unknown compound X, the unknown enthalpy change. The unknown enthalpy change was heat of vaporization. Now look at here. Now look at the formula. Heat of sublimation is equal to heat of fusion plus heat of vaporization. Now heat of vaporization is equal to, bring this one here on the other side of equation. It will be minus heat of sublimation minus heat of vaporization. Here the heat of sublimation is 200 kilojoule minus heat of vaporization is 8 kilojoule. Okay, 8 kilojoule. So you will get the answer of 192 kilojoule. Here option A is correct. Okay, look at here. This vaporization is 192 kilojoule. A mixture of ice and water contains 60 grams of ice and 60 grams of water. If 60 joule of energy is removed from this mixture, then some of water will freeze. Here option D is correct, because we know that when water is converted into ice, it will release energy. Here in this MCQ, 60 joule of heat energy is removed, so the water will freeze at that temperature. Now look, water will vaporize. This one is incorrect. Okay, when we give energy to this water, okay, when we give energy to this mixture, then in that case the water will vaporize. The ice will sublime. When we give energy to this mixture, some of the ice will sublime. Look, some of the ice will melt. When we give energy to this mixture, then in that case there is possibility that ice will melt. Now look, the energy is removed, so in this case water will freeze. Look, for example, when we put the water in a freezer, then what the freezer do? The freezer remove the heat from the water. Okay, the freezer remove the heat energy from water, and in that case the water is converted into ice. So this is the option D is the correct option. Zinc powder is sprinkled on aqueous solution of copper sulfate. Copper sulfate solution decolorizes. Copper sulfate is blue in color. Okay, when zinc powder is sprinkled, then what will happen? So this is a spontaneous process. Okay, because this reaction occurs without the interference of any external source. Okay, without giving any energy, this reaction occurs. So this one is spontaneous process. The zinc will replaces the copper, and in that case zinc sulfate will form. Okay, so synthesis, this is incorrect. Decomposition is also incorrect. Okay, so it means that spontaneous process is correct. Look at the next one. Dissolution of sodium chloride in water is a. Now we know that when we dissolve sodium chloride in water, then it is a spontaneous process. Okay, like when we dissolve sodium chloride, we put the salt in water, then we don't have to provide any energy in order for its dissolution. So it means that this is spontaneous process and endothermic process. Endothermic in that case, like it do not require a large amount of energy for its dissolution. Okay, it required very less amount of energy. In that case, we don't have to give it heat energy. Okay, it occur on its own, and it observe the heat from its environment. So spontaneous mean that it occur on its own, and endothermic means that we don't have to provide any energy for this reaction. It gain the energy from the environment. Okay, it required very less amount of energy. That's why it can gain it from the water or from its environment. Look here, option D is correct. Okay, spontaneous and endothermic. Calorimeter is an apparatus used for the measurement of heat of the reaction. Option C is correct. Born-Haber cycle is used for the measurement of lattice energy. Okay, this cycle is used for measurement of lattice energy. Look, 33. In the equation x is equal to E plus PV, x represent. So here x represent the enthalpy of the system. look, enthalpy of the system, like change in heat is equal to energy plus P and V. Okay, this is the enthalpy of the system at constant pressure. So this one was the last MCQ of thermochemistry. If you have any problem in any MCQ, then write in the comment section. Allah Hafiz.